Hi everyone, welcome to New Year. It's January 2026. So what are we gonna do today? So as part of my self-improvement for this year, I've decided that I'm going to take some time out every month from work, and I'm going to make a rudimentary DigiCam. So this is some sort of camera, something that we understand as a camera, but basically is going to be a combination of a microcontroller unit or a master unit and an image sensor and a display unit. So we can move images from the image sensor all the way through the microcontroller to the display unit, and then we can see about how we can build improvements into this. So it happens to be that the first one that we've done is one that uses the Nucleo N6 and Sony IMX219 camera and the Zephyr operating system, real-time operating system. So let's think about this. So what do we want to do? We want to achieve something that looks like something that is a digital camera. So let's look at what a digital camera is. Digital camera. So images, or rather, I see a good solution here. So let's see what a digital camera is. Yeah, cool. A digital camera, also called a DigiCam, is a camera that captures photographs in digital memory. Most cameras produced since the turn of the 21st century are digital, largely replacing those that capture images on photographic film. So cool. So yeah, basically we want to capture images on, so this is kind of what we want. This is where we're going to start. As you see here, they have a display, they have an image sensor, and they have some sort of processing unit in the middle. And what we want to do is basically start by being very simple and end up cobbling up this whole thing in a very advanced kind of way by the time we're done with all of this. So right now we're going to start really simple. We're going to be based on a dev board, and we're going to be based on a dev image sensor, and then we're going to climb up the ladder slowly with that. And surprisingly enough, it's kind of rudimentary. It's quite easy to get to the beginning steps of this, but then as you go farther and farther on this, it becomes very difficult. So right now we have some sort of a sample. How do I show you this? What I'm gonna do is I'm gonna grab I want to put it this way so you can see. So this can see my image, something like that. I want to try and position the camera so it can see me. So I'm going to grab my webcam and I'm going to point out to the little system that I have in front of me, and then we'll basically go to the code. So here we go. Can I do it this way? Perfect. So I'm waiting for it to see. I'm waiting to see that it's actually showing the correct thing. So here we have a Nucleo N6 570XQ, and then here we have a Raspberry Pi 2 V2 camera, which is it's based on a Sony IMX219 camera. This is one of the most prevalent cameras. It's very popular, you can forget it, and the data sheets for this are sort of everywhere. So what I want to do is I want to make sure we can see this camera here, and then next to it there's a little display which is going to be very difficult to show. There's a little display that is going to be quite difficult to show. So there's a display here that is actually showing a buffer of an image of me pointing a camera at it, but I am unsure on whether this is going to translate into the video. properly. So there you go. As you can see, that's the video camera, and behind that is my face, and then there's a camera here which is next to it, and then yeah, and a processing unit and a display. So cool. And you get a tour of my old desk as you go along. So there you go. That is what we're doing. We're based on our Nucleo N6. We have a Sony IMX219 digital camera, and we have a digital image sensor, and we have a Waveshare 2-inch LCD display. So let's go on. I'm just making sure it's in the right place. So let's go on and just basically get started. Let's just get started and see. So the way I started this out is by I started here, GitHub. I started out by working with a lane, and with a lane and the video work group on Zephyr, and basically I started by helping testing the driver for the IMX219 device, which is the driver is here. So okay, the driver for that device is here. Repositories, Nucleo IMX219. So here's the driver. This is the driver that we're depending on, which is the drivers add IMX219 sensor RPI Cam V2, and it replaces another PR by Joshua, who is also very strong member of the video team in Zephyr. Cool. So that's the first thing. We had to get the video driver for this thing happening, and then after that, we also had to the other thing that needed to be done, or that was already done, was making sure that the Nucleo N6 Nucleo N657, this one, has a CSI, which is a camera serial interface section. So this has this little white section here. This is a CSI peripheral, and that CSI peripheral enables it to be connected to the CSI capable camera. And in this Nucleo N6 we have a DCI-MPP peripheral, which is a digital DCMI-PP. It's digital camera interface pixel pipeline, if I remember. So it's not the normal STM32 DCMI. This is digital camera interface pixel pipeline. So it allows us to have a few pixel pipelines, and we can see those here. So actually, do I have even the reference manual is fine. So here, I'll open the DCMI. Any questions so far? Can't believe my internet is that slow. So cool. So here you're going to see we have a digital camera interface pipeline, DSMI, DC. It has both of them. So it has a digital camera interface, and then it also has a digital camera interface pipeline, pixel pipeline. So the DCMI MPP is a pixel pipeline section of a high resolution camera subsystem. It gets pixels from a parallel or a CSI interface, and then after some processing such as decimation, cropping, downsize, color conversion, gamma correction, and exposure, dumps them into memory. So this allows us to operate on pixels as they come through. And you can see here there's a dump pipe that is just the plain. It's just plain, and I'll show you these right now. It's just the plain pipe. And then there's a main pipe, which is the one that is actually used right now. And then there's an ancillary pipe just used for whatever other reasons you want. So if you want to see those pipelines in particular, you will have to come here. You'll have to come here and then find this document. find that document in Zephyr Artus, or rather find that file. So this file, you want to find this file, which is in the HAL. It's usually in the HAL somewhere, isn't it? Isn't it in the HAL? N67. Or maybe that's the DTS one I'm thinking about. So Control F, pipes. Okay, so cool. As you can see here, they are just denoted like in the data sheet. So the pipe, there's a pipe dump, there's a pipe main, there's a pipe auxiliary, and this one's go with these three ones here. So for these purposes, we're going to be using the main pipe. However, when we go down the line and we actually start messing with things, we might be able to use the other pipes, or we might have reason to start using the other pipes. Typically, the main pipe is typically used for the main needs such as video encode, software analysis. Just one moment. I need to. Sorry about that. I'm back. Cool. So let's look at it. Typically used for the main needs, and that is way too small for you guys to see. Typically used for the main needs such as video encoding, software analysis, neural network, and it allows the to downsize the input, convert its color, dump to multiple pixel formats, include multiplanar ones. It can adapt luminosity and as well as auto exposure, black level calibration based on its own embedded image processing functions, handling without an internal ISP. It can convert raw Bayer to RGB, demosaicing. Pipe 1 shares all the image processing functions with pipe 2. And then pipe dump is just, you want to get, you basically are going to the old school. You're going to DCMI, where you're just getting plain pixels as they're coming through. Okay, cool. So we had to make sure this was already developed in the DCMI drivers. So in the DCMI drivers, you'll see here we have DCMI MPP, which is this. And if we go and find that, we will find a driver for that. I actually know where that driver is. So let me take you there. It's in drivers, and I think I've messed with it before on stream. It's in drivers. It's in drivers video, and then it's gonna be somewhere down here. SDMI, DCMI, PP. So here's the driver for. It's quite huge. It is quite huge. That looks like a 5,000 line or something, or 4,000 line, 2,000 line. Okay, cool. So here's the driver for just basically doing pixel processing with DCMI and PP. So we had to make sure that was developed as well. So we have a camera interface driver. We have an image sensor driver, and we have the RTOS. And then if we combine all of this, we can basically build up an application. And that happens to have been done for us already. So Zephyr video sample. I wonder if the DCMI MPP allows us to do So I want to see the video API for this thing. Video, device API. So it says a set format, get format, set stream, enqueue, dequeue, get caps, frame interval, set interval, set selection, get selection, and no controls yet. Set format. So what I want to find is this one. Oh no. So let's go find this one. So I'm trying to find out if ooh, that's very yeah, what I'm trying to find out is can we do ISP functions? This is just decimate. Seems like whenever I decimate, I don't think we have there's a crop Robert to RGB. I am talking to the void, obviously. I'm trying to see if there's a way we can do some conversion so that we can actually start seeing video of a certain type. If we can set format or do a color conversion. I think we can go into here and check what yeah, we're getting frames, that's fine. What I want to see is what frames are we no, it's already jumping into that. There's digital gain, solid color bars. Okay, so let's go into our code. Start working with the code. What I want to do is set up display. This is fine. I don't care to do about the display. Set up display frame, video selection. That's okay. Cropping, that's fine. What I don't want to do is print the cups. So if I remove cups, can I get all the other logs so that I can actually see what is happening? So let me build that. I'm gonna put this thing in bootloader mode. I should ideally use SB. Just flash. I should ideally use SB. Okay. So I also don't want to show controls, I guess. Yeah, I also don't want to show controls for now. Control, what is that device? I want to remove most of those logs. So this is log inf here, and I think this is coming from inf video controls. So let me see. What are our logs set to? I would like to reduce cut build Zephyr .config grep video. Okay. Okay. So let's only one video log level 1. Yes. Will that build? So I want to remove. What I'm trying to do is remove all this. Remove all these logs in the beginning. These ones, these video control ones. I would like to remove all of these and remain with just a few up here. And also probably I just want to capture one frame and just stop at that, because I don't want to do while true. I would like to do just capture one frame and see if we can get the hex dump of the frame and put it out and see if we can debate it to something else. So that way we can try and put the frame on the big screen, on the computer screen, and see if that actually works out. so let's do that. Let's reboot. Oh. Now I have to flash again because it's here. Okay, I'm gonna go here and I'm say reboot. So video device, composed window, video format RGBP, supported frame intervals, default frame rate level 15 frames per second, device camera 10, display device ST7789 at 0. Let's actually just capture one frame so that we can actually do the camera part of this stream. Let's capture just one frame and we stop there. So I'm sure there's a point down here where we capture many frames. Frame number. Let's add an int. Eventually you can put this behind a button, but for now let's just put it in an int, and so that way we just int frame no is equals 0, and then let's go here and then say while frame no while frame no is less than 2. Okay, it's actually, yeah, let's do 2 frames, and then let's go down here at the end and then say frame no plus. Okay, and then what we're going to do here is we're going to West flash this, West build. The aim is to actually just do all of it in software. It's just capture an image. Yeah, this is fine. And did I do a thing at the top where I started? Yeah. So the aim would be to just capture one frame and see if we can just hex dump it. And then if we can hex dump it, we can probably copy it and see if we can use some sort of image processor, image signal processor to make that whole thing into an image. But I'm not so sure right now. I'm not so sure about RGB 565. We'll figure it out. So what do we want to do now? We want to flash this thing. I really should go to serial boot, but I don't want to add another cable. There's so many cables on my desk. First flash. Let's flash it. Perfect. So that's flashed, and I want to go back. I would like to go back here, and then I'm gonna do a reboot. Let's go here. I'm gonna do a reboot here. Boom. Error, aborting sample. Main, aborting sample. Wait, why is it aborting sample? Oh, I see. There's something about here, so it should go here. Yeah, that's fine. That's okay. It stops. That's okay for now. That is perfect what we want. So what I want to do is probably capture one of these frames. We know all this other data. We know that it's 120 by 160. We know all this. We know it's RGB 565. Perhaps we can hex dump this frame. So let's go here. Logging Zephyr hex dump. So I want to actually dump the whole frame. You see this? Yeah. So what I want to do is this: log info hex dump. Log hex dump. Let's actually that. I want to try and dump a frame, and let's actually do here. Let's make it just so that it dumps one. Okay. Okay, so that it just does one, and then when we get here, got frame. Where is the frame? Where is the frame? So the frame itself is where? It's here. This is frame number though. Display device, vbuff and format. Vbuff is our frame. So vbuff is our frame. So we want to go log inf hex dump. The problem is this is not a row. This is not row bytes. So hex dump inf log hex dump inf, and then we want to say what? Vbuff size of vbuff. Actually, we can check inside vbuff itself, and we can actually check inside vbuff itself and actually get our own the buffer itself, which means going to learn what is in the video buffer. But let's actually do this first. Frame first frame. I want to see what we get, and then let's go here and we can do that, and we can do that, and we can do that, and then we can go into here. We can build the application with it. Build inside video frame video buffer. There's going to be the actual frame. The actual frame is our raw image. Our raw image we can use an ISP on, which is an image signaling processor processing application right now, and we can try and make that into an image. So let's actually just do this quickly. Cool. So let's flash this on. See if we actually get a frame buffer itself. We're going to do a west flash. And do I have any questions? Let me check. Do I have any questions? No questions so far. If you have questions, you can ask. Feel free to ask them. So that's flashed. And then let's go here. And then what I want to do is do that. Go put it back into boot, and then so that's not what we want. It's dumping the pointer. We don't want it to dump the pointer. Arjun Gupta is asking what exactly you're doing. Hi Arjun, we are trying to build a digital camera from NC and I'll show you. So we have an MCU, we have an IMX219, and then we have a screen. There you go. So what we're trying to do is build a digital camera that captures images from the image sensor into the display. And right now, what we're trying to do is get a dump of the frame buffer that we're getting from there. So the first thing we need to go and do is find out about Zephyr API. So let's go find out about the Zephyr API, and then what we want to do is find out about the video buffer. this is a data structure. It's a struct. So this is a struct we want to find out about. VBuff. So video buffer, this one. We want to find out about this. And what we want to know is what it contains. That video buffer struct. So it contains, there you go. It can the driver data, the type, and the buffer itself, pointed to the starter buffer. And then index size of the buffer in bytes. So this. So what we want to do instead of that, we want to do hex dump hex. Okay, so here we want to do so let's see, hex equals we want to go to hex buffer itself, and then size of vbuff buffer, actually size. So we don't even need that. We can just remove all of this, and this should be our first frame. I want to get it completely raw, but let's start here and see if we can actually get let's start there and see if we can actually get something that we want. So Arjun, I hope I explained myself clear. Oh yeah, hi Arjun. Using an inbuilt accelerometer on the STM32F47. That must be very old. But sure, you can. Was that on Zephyr or was that on bare metal, Arjun? I think that was on bare metal. That must be a very old video. But yes, you can ask questions if you want. By the way, if you can join, if you want to ask questions like after and on particular topics, in the description there's a link to a Discord, which is a community. You can join and we can always discuss that about the inbuilt accelerometer. I think I also did a Zephyr video where I started working on the inbuilt accelerometer, because that accelerometer is actually not covered in Zephyr, and the reason it's not covered in Zephyr is because it's too old. So basically it's obsolete to ST themselves. So if we are gonna cover it, we have to put it outside. It's a very simple thing. It's a very simple, a few registers here and there and a few settings, and it should work really well. So let's do a West flash here. Amazing. So we've got a flash, and then what I want to do here is I want to go there, and then I want to reboot. So that's not good. That didn't work the way we wanted it to work. That did not work the way we wanted it to work. So something went wrong there. Something went wrong there. Log. Hex dump. So something wrong went wrong. Data length string. So why didn't that work? Log row. length of data in bytes. And then what do we want? What we want to discover is video buffer. Should be somehow we're missing something here, but we'll find it just now. Video buffer here. So video buffer, pointer to the start of that, index of the buffer optionally set by the application, size of the buffer in bytes. So this is size of the buffer in bytes, pointer to that. So we can't start by just logging those two and see if it actually logs them. And where did we crash this time? One message dropped. Why was a message dropped here? And previously, fast frame. Capture started fast frame. So previously that worked. Fast frame worked. Okay, cool. So let's just first of all get here, and then actually let's look at these so that we know timestamp, line offset. Okay, by validate and buffer. So, okay, cool. Oh, wait. Number of bytes occupied by the valid data in the buffer. So bytes used. So that's actually what we want. So first of all, let's do a login to just know that we're getting the buffer is at pointer, and then size is a D, and then bytes used is also a D, and then Ooh, this is actually quite interesting. Check, we'll do something funny here. Okay, cool. So let's actually see that, and then we can go to vbuff. So here is buffer. So that's a pointer, and then vbuff. So the next one we provide is bytes used, and then I would like this to be the new line, and then the next one is on the vbuff size, and because it's not going to overwrite it, we don't have to. Yeah, I won't actually do that. I won't do that. Where we don't have to DQ it, so that's fine. So we never get to DQing it. We are bot. So let's actually do this, and then this might actually even work out. So let's West build. See if there's any more questions. Yes, Arjun, welcome to join the Discord community. Welcome to ask questions there so that we can cover the questions that you have there on that. And you're welcome to request a video on that if you want. Okay, cool. So let's see if we can get some buffer there. So West flash. Okay, perfect. See here. Amazing. Bytes used. Size and bytes used is the same. That's okay. I don't care about that. That is fine. So there's a command that we have that is called devmem. and then it has a dump help. So mem dash address dash size. So we can note dev mem dump dash a 0 cross 34. This might be garbage, by the way. 3419 CF70, and then dash S 38 400. Okay, this is our first image. This is an image that has been captured by the device, and it's going to be very, very long. What I need to do is find a way of dumping this into a file somewhere, or into the file system. Perhaps we can use USB, and we can use something like CDC, and then we can use CDC to send this image over. And then once we use CDC to send the image over, we can use CDC to send the image over to the host computer. And then on the host computer, we can take that buffer and we can actually go process it as a file. That might be a cool way to do it. So, but what I'm showing here is that we can, so there you go. So what I'm showing here is that there's an image, and that we can capture it, and we can basically we can operate on it. A lot of 82s, a lot of cross 82s there, a lot of cross 82s. So those must be some sort of limit. But here we go. It was supposed to be an hour stream. Does everyone have any questions on image signal processing? This is the January installment. So basically, I'll recap. As you can see here, we have a display, and it shows a little video on it. And on the video, there's we have a feed that is coming from. Let me see. Oh, I remember. It's because I've turned it on. We have a feed that is coming from the IMX219, and what the aims for February becomes is, the reason this video is so small right now is not the full image, is because the Nucleo has very little RAM. It does have external flash. The best thing to do right now is to build it up so that it can be it can run in external flash. I do have a PR open on this. There's a Nucleo PR. I do have a Zephyr PR on this at the moment. Nucleo. So I think here we can go here. We can go. I do have this PR. So no, this one. No. Probably. Where is this? Where is it? So this one, this PR, I do have this PR that is on I need to complete this PR, and this PR will basically enable us to run everything on external flash, which will give us a lot more RAM. And once we have a lot more RAM, we can use the complete display, and which will be clearer to show, and we can actually start manipulating the images. Right now we're limited by code size. So what we want to do is fix the code size problem, then we can start actually enhancing the camera. So the first thing to do for the second month, for February, is going to be enable this thing to run on external flash, and then perhaps dump an image, dump a frame from the application into the host, using something like CDC, and then we can probably do image signal processing of it there, and then we can start adding image signal processing on the device as we go along, and as we do more installations of this. Let me see, are there any questions? Arjun has a question. I'm a second year student doing my engineering, and I have my course project about STM32 audio capture and store from F47, and I want to know how to start as I am a noob in this. Well, if you can do GPIO, just start extending it towards you have to have a more specific question for me to be able to help with that, to be honest, Arjun, because I don't know where you're stuck. The first hint is to get stuck somewhere. I'm using this for the first time. Okay, sure, we're all doing. I'm also the thing I'm doing today is I'm also doing for the first time. So welcome. I have read the datasheet and somewhat about the architecture between difference between board, and somewhat about the Cortex M4. Now what to do? I would say break down your problem. If you have an audio project, break it down until you identify where you're going to start. What is it that you need to start with? So and for this you have to start at the end. So you have to start with what do you need to build in the end? What is the smallest part you need to do? What is the smallest part of that smallest part that you need to do? And then build out on that, and then keep adding until you get to the end. That's really the best way. So define what you're aiming for, and then start breaking it down until you have day by day actions that you can take. That's my advice for that, Arjun. I hope that helps. Any more questions? Well, thank you so much. That's been an hour stream. That's been the January installment of our DigiCam. Let's go work on this MCU boot for this applications for this board, so that we can start using the external flash. And once we can start using the external flash, we can have quite beefier code, and even we can even start using the external flash for actually storing images and sending them over to the device via actually something like MSC or something of the sort, a mass storage device over USB, and that would be much easier, because then we can just store a frame, get onto the device, copy the frame, and decode it on the host, and then we'll probably end up adding image signal processor on this, and or use the onboard STM32 signal processor. We might need to add some drivers for that, and we can build up slowly until we have like a really nice looking digital camera. And maybe somewhere along the line we can learn how to use boards and build boards, and then once we can learn how to build boards, we can actually put this on its own board with the cameras and everything in place and using them properly. Other than that, thank you so much for attending the stream today. Cheers, and see you soon. I'm really happy to start streaming this year. It's I had a post for January, and I think we've gotten to the end, and this is awesome. Thank you so much. Cheers and welcome, and see you in the next one. Amazing.